Hello guys, this is the chapter number 5 of the part first of the course Quantitative Aptitude and Reasoning. In this chapter we will study about the percentage and its usages and applications in the real world. Viewers, percentage is the most used concept of our daily life, and it is asked in all the competitive examinations including NTS tests, lecturer test of different public service commissions including Federal Public Service Commission, Punjab, KPK, and it is applicable in almost in all the countries competitive examinations. Viewers, percentage means per 100, out of 100, 1 over 100, per means out of, and cent means 100. So if we take something out of 100, so that means percentage. For percentage we use this symbol and we write percentage of something 1 over 100, that is to find percent of some number, so we just multiply that number by 1 upon 100. Okay, so if we are asked to find out 5%, so it just means 5 over 100. Okay, it's easy concept, but in our daily life there are so many situations in which it becomes complicated. So there are some theorems in this chapter. We will study their theorems, and based on these theorems we will try to solve the examples. So be tuned with us and be alert. Okay, a fraction whose denominator is expressed as 100 is called the percentage, and the numerator of the fraction is called the rate percentage. For example, a man spends 10% of his monthly income on dress materials, means every 10 rupee out of 100 rupees he gets goes to the purchase of dress materials. That is, if the monthly income of the man is 5,000 rupees, then the spending towards dress materials comes about 10 over 100 into 5,000 gives us 500 rupees. In an example 1, we are given that in an election there are two candidates. The candidate who gets 46% is rejected by a majority of 2,688 votes. Find the total number of votes polled. So in this example, we are given that there are two candidates. First candidate who rejected by the voters gets 46% votes. So obviously the second would have to get 54%, that is 100 minus 46 is 54%, and by how much majority he is passed, so 54 minus 46 gives us 8%. So by 8% the winning candidate is passed. So now the problem is that how much votes were polled in that contest. So votes polled are, we are given by majority he obtained 2,688 votes, and he get in the majority 8% of total votes. So we have to find out the required answer by 2,688 by 8%, divide by 8%, so 8 by 100, so we get 33,600. so the total votes polled are 33,600, and the winning candidate get 2,688 vote more than the losing candidate. Okay, so this is an example based on percentage. Okay, the next example is what percentage is equivalent to 5 over 8. So 5 over 8 is now a fraction. So from now onwards, when we are asked to find out the percentage of fraction, so it's just simply we have to multiply that fraction with 100. So I multiply 5 over 8 into 100, so I get 8, 4, here is 50, then it's 2, then it's 25, so 25 5s are 125 over 2, and if we divide 125 by 2 we get 62 whole 1 over 2%. So 5 over 8 is equivalent to 62.5%. Okay, in the example 3, we are given that the salary of Canon is increased from 3500 to 4025 rupees. Find the increased percent. Okay, so this is a very interesting example, and the most uh, servants will be dealt with this example. They are oftenly uh, calculating their salary, that how much percentage their salary will be increased, and if some percentage in increase is nominated or announced by the government, then this is for those that how to find out how much their salaries will be increased. So now the present salary of the man is 3500 and it is increased to 4025. So how much increase here? 525 rupees his salary is increased, and his initial salary was 3500. So in order to convert this, we just have to multiply this to 100. So 525 over 3500, which was the actual salary, now increased by 525 rupees. So in percent, we have to multiply it with 100. So we get 15% increased into 15%. In the example number 4, we are given the price of sugar in the market rises by 25%. A person whose income is fixed has to reduce the consumption of sugar so that the expenditure remains the same. By what percent he should reduce the consumption of sugar? So now in the market, sugar prices are rises by 25%, but the income of that person is the same, and it's constant and not changes, and he wants to reduce the consumption of sugar because his income is not changed. So by what percent he should reduce the consumption of sugar? So for that we use the reduction formula percentage, that is he will reduce by 25%. So we can write 25 and multiply it with 100 by 100 plus 25. So we get 20%. It is actually the formula x into 100 over 100 plus x, and x is the increase rate, increase rises in percentage. Okay, theorem number 1, if the price of a certain item is increased by x% and then increased by y%, then the resultant increase in its price is given by the formula x plus y plus xy over 100%. Okay, for example, if there are mangoes and its price is increased by 5 rupees first, then by 10 rupees, then the resultant increase in price is given by 5 plus 10 plus 5 into 10, 50 over 100. So 50 over 100 gives us 1 over 2, 5 plus 10, 15. So 15 plus 1 over 2, and it becomes 30 plus 1, 31 by 2 or 16.5%. So the increase in percentage is 16.5%. Okay. In theorem 2, if two values are respectively x% and y% more than the third value, then the first is 100 plus x over 100 plus y into 100% of the second. Let this apply this to the following example. We are given two numbers are 25% and 50% more than a third number. What percentage is the first of the second? So by theorem 2, the required value is 100 plus x means 100 plus 25, and 100 plus y means 100 plus 50 and 200, and it gives us 83.5%. Okay. So if two values are respectively x and y% more than the third value, then the first is 100 plus x over 100 plus y into 100% of the second. In the theorem 3, we are given if P is x% of R and Q is y% of R, then P is x over y and 100% of Q. Okay, so two values are given that the first is x% of the third number and the second is y% of the third number. Okay, so both of them are x over y into 100% of each other. In example number 6, two numbers are 24% and 30% of a third number. What percentage is the first of the second? So by theorem 3 we have to find out the required value x over y, that is 24 over 30 and 200, which gives us 80%. Example 7. Two numbers are 20% and 40% less than a third number. What percent is the second of the first? Now here is the reduce phenomena discussed, that is two numbers are less than a third number, so here we use the minus symbol. The percent of the second number with respect to the first number is given by 100 minus 40 over 100 minus 20 into 100, which is equal to 75%, and this is by using theorem number 2. Okay, percentage, expenditure and savings. If a person spends X% of his money on lodging and Y% of the remaining on food and cloth expenses, and M is the amount remaining with him, then the amount he had at the beginning is given by M into 100 into 100 over 100 minus 6 into 100 minus Y. Example number 8. A person spends 5% of his income on income tax and 12.5% of the remaining is saved. The amount spent was 29,925 rupees. What was his income? So his income is given by the formula M into 100 into 100 over 100 minus 6 into 100 minus Y. So it's equals to 29,925 into 100 into 100 divided by 100 minus 5 into 100 minus 12.5, which gives us 36,000 rupees. Okay. Another theorem is, if X% of a quantity is taken by the first, Y% of the remaining is taken by the second, and Z% of the remaining is taken by a third person, and if the amount left is P, then the amount at the beginning is given by P into multiplied by 100 3 times and divided by 100 minus 6 into 100 minus Y and 100 minus Z, where X, Y, Z are the quantity taken by first, second and third and percentage. The next theorem is, if X% of a quantity is added, Y% of the increased quantity is added, and Z% of the first increased quantity is added, and the amount becomes P, then the initial amount is given by P into 100 into 100 into 100 over 100 plus 6 into 100 plus Y into 100 plus Z. Example, a certain sum was first increased by 10% and then by 20%, and it became finally 5,280 rupees. Find the initial sum. So the required initial amount is given by 5,280 into 100 into 100 divided by 100 plus 6 means 110 and 100 plus Y means 120. So we get 4,000 rupees. Population formula is also one of the real world example or application of percentage. If the original population of a town is P and the annual increase in population is R%, population after n years will be P into 1 plus R over 100 whole power n. This is very important formula and this is asked in many examination. Here P is the population current, R is increase in the population, and n is the number of years. Okay. Here is example 10. We are given annual increase in population of a town is 4% and the present population is 40,000. What will be the population of town after 2 years? So we use the formula P into 1 plus R over 100 whole power n. So by that formula we get the required population after 2 years. If the current population is 40,000, is 43,264. The next theorem is, the population of a town is P. It increases by X% during the first year, Y% during the second year, and Z% during the third year. Population after 3 years will be P into 100 plus X, 100 plus Y into 100 plus Z, or 100 into 100 into 100. For example, in example number 11, the population of a town is 15,000. It increases by 10% for the first year, 20% for the second year, and 40% for the third year. What will be the population after 3 years? So the required population is 15,000 into 100 plus 6 means 120, then is 120, then is 140 over 100 into 100 into 100. So we get 27,720 is the population after 3 years if the current population is 15,000. Example number 12. The population of a town increases at the rate of 10% during the first year and it decreases at the rate of 5% during the second year. If it has 20,900 inhabitants now, what was the population of town 2 years ago? So the required population is 20,900 into 100 into 100 over 110 into 95, so we get 20,000. Theorem number 7. Let the present value of a machine be P. Let the depreciation of the machine be at the rate of R% per annum. Then value of machine after n years is P into 1 minus R over 100 whole power n. And value of machine n years ago, that is before, is P over 1 minus R over 100 whole power n. Example number 13. A machine costs 320,000 rupees at present. If the value of the machine depreciates at the rate of 5% per annum, what will be its value 6 years hence? So present value of machine is 320,000. 6 years hence value of machine is 32,000 into 1 minus 5 over 100 whole power 6, which is 235,229.41 rupees. Percentage relationship. If A is x% more than B, then B is x over 100 plus x into 100% less than A. If A is x% more than B, then B is x over 100 plus x into 100% less than A. Similarly, if A is x% less than B, then B is x over 100 minus x into 100% more than A. Okay. There are some examples. These are left for you. Try by yourself. Example number 14. Okay, and theorem number 9. If a number is first increased by x% and then decreased by x%, the net change is always a decrease which is equal to x% of x or x square over 100%. Try this example by yourself. Theorem number 10. The pass mark in an examination is x%. If a candidate who secures y marks fails by z marks, then the maximum mark is given by 100 into y plus z over x. Example. In an examination, a candidate requires 35% more marks to pass. If he gets 90 marks and fails by 50 marks, find the maximum marks. So the maximum marks are given by the formula 100 into y plus z over x. 100 into 90 plus 50 over 35 equals to 400. Okay, so this is all about the percentage. I think you people learned this concept well, and also we discussed the theorems and examples related to percentage. So thanks for watching this video. Please subscribe my channel and share.